Welcome to the DIY Honda Garage channel. In this presentation, we will discuss the Diagnostic Trouble Code, DTC P2565, which indicates a high voltage issue in the Turbocharger Wastegate Control Actuator Position Sensor Circuit for the Honda CR-V models from 2023 and onwards. This code suggests that the output voltage from the Turbocharger Wastegate Control Actuator Position Sensor exceeds the specified threshold. The Powertrain Control Module, PCM, which interprets this signal, determines that an abnormality exists and subsequently stores the DTC. The turbocharger plays a vital role in optimizing engine performance by boosting air intake, making the Wastegate Control Actuator Position Sensor crucial for regulating boost pressure effectively. As we move through the troubleshooting steps, we will examine the sensor, related circuits, and the PCM to identify the root cause of the issue. DTC P2565 pertains to the Turbocharger Wastegate Control Actuator Position Sensor, which is critical in managing the turbocharger's operation. The sensor's role is to monitor the position of the wastegate, ensuring proper boost is generated for optimal engine performance. If the sensor's output voltage exceeds 4.87 volts, it indicates an electrical issue, detected by the Powertrain Control Module, PCM. The PCM's primary function is to oversee engine functions and ensure efficiency. In the Honda CR-V, the turbocharger and its wastegate actuator are located within the engine compartment, typically near the intake manifold. Proper diagnosis of this DTC requires examining all related components, including the sensor and any wiring harness connections that may exhibit faults or shorts. There are several potential causes for DTC P2565, and each must be examined systematically. The primary cause is often a high-voltage signal from the Turbocharger Wastegate Control Actuator Position Sensor, which can be attributed to internal sensor failure. External circuit issues may also arise, such as short circuits or open circuits due to damaged wiring or poor connections, which can deliver incorrect voltage readings to the PCM. Another possibility is a malfunctioning PCM itself, which may misinterpret valid sensor data as false. In addition, general wiring damage, including corrosion or physical wear, can disrupt the communication between the sensor and the PCM. Therefore, thorough inspection of both the sensor and the associated wiring is critical. The symptoms associated with DTC P2565 can manifest as noticeable changes in vehicle performance. One of the most common signs is a reduction in engine performance, which might present as sluggish acceleration or difficulty climbing hills. Additionally, the check engine light will illuminate on the dashboard, alerting the driver to a fault in the engine management system. Drivers may also experience turbocharger performance issues, such as reduced boost pressure or turbo lag, which can lead to further complications. In more severe cases, the vehicle may stall or hesitate, particularly during acceleration when the engine relies on the turbocharger for additional power. Recognizing these symptoms promptly can prevent further damage to the vehicle's engine components and ensure timely repairs. The first step in our troubleshooting process focuses on verifying the HDS reading, specifically the EWG voltage from the lift sensor. Start by turning the vehicle to the on mode without starting the engine. This allows the PCM to perform a system check and display real-time data. It's crucial to monitor the HDS readings to see if the voltage exceeds the specified limit of 4.87 volts. If the reading is higher than this threshold, the fault is confirmed. This isolation step helps to replicate the issue and aligns with the PCM's determination of an abnormal condition, substantiating the presence of DTC P2565. In this step, we'll perform a more thorough inspection of the Turbocharger Wastegate Control Actuator Position Sensor. Disconnect the turbocharger's 5-pin connector to isolate the sensor from the circuit. Using a jumper wire, connect terminals 3 and 4 of the disconnected connector. Next, turn the vehicle to the on mode again and check the HDS for the EWG voltage from the lift sensor. According to the diagnostic protocol, a normal condition would be a voltage reading of less than 4.87 volts. If the voltage remains high, it indicates a deeper issue with the turbocharger itself, while low voltage readings could suggest that the problem lies within the external circuits or PCM. This step involves inspecting the external circuits leading to the powertrain control module, PCM. Begin by disconnecting the PCM connector, specifically connector E, alongside the previously disconnected turbocharger connector. With both connectors disconnected, perform a detailed inspection of the DCWGL and SG2 wires according to the service manual guidelines. You will need to measure the resistance of these circuits. Normal conditions indicate a resistance of less than 1 ohm. If you observe higher resistance or an open circuit, there is likely an issue in the wiring, leading to the high voltage problem noted earlier. Thus, evaluating circuit integrity at this stage is crucial for solving the DTC. The final troubleshooting step evaluates the powertrain control module, PCM, if all prior inspections yielded normal conditions. If both the turbocharger wastegate control actuator position sensor and its associated circuits check out, the PCM is likely the source of the problems. The PCM processes inputs from the various sensors, and any malfunction can lead to incorrect voltage readings, triggering the DTC. If the inspection confirms that all other components are functioning correctly, it suggests that the PCM requires replacement or reprogramming. This determination is essential to rectify the high voltage issue indicated by DTC P2565. After completing all necessary repairs, it's vital to verify that the issue has been resolved before concluding the troubleshooting process for DTC P2565. Begin by rechecking all electrical connections and ensuring they are secure and free from corrosion or damage. Following this, use the Honda Diagnostic System, HDS, to clear the DTC from the vehicle's memory. Once cleared, conduct a test drive to ensure that the issues regarding turbocharger performance have been resolved and no new DTCs are triggered during normal operations. This verification step ensures the integrity of the repair and confirms that the vehicle operates as expected. To prevent the recurrence of issues related to DTC P2565, regular preventive maintenance is essential. Routinely inspecting the wiring harness associated with the turbocharger wastegate control actuator position sensor will help to identify potential problems before they escalate. Additionally, ensuring that connectors are clean and free of dirt or moisture can significantly reduce the chances of electrical faults. Drivers should also monitor turbocharger performance during regular maintenance checks. Any unusual sounds, loss of power, or changes in acceleration should prompt immediate investigation, allowing for proactive interventions and sustaining optimal vehicle performance. In conclusion, understanding DTC P2565 and its implications for the turbocharger function is crucial for Honda CR-V owners. From identifying high-voltage causes related to the turbocharger wastegate control, actuator position sensor, to following a systematic troubleshooting approach, effective diagnosis ensures timely repairs. Regular preventive measures can help avoid such issues in the future, maintaining vehicle performance and reliability. Addressing DTC P2565 swiftly and thoroughly can result in a smoother driving experience, enhancing both safety and performance for the driver. Always refer to Honda's guidelines and diagnostic systems to ensure compliance with recommended procedures. Please like and subscribe to the channel. See you next time!